All right, so this first problem from chapter 5 is a piston going up and down in simple harmonic motion. All right, so the piston is going through a sine wave up and down, straight up and down. All right, and there is a block sitting on top of it. All right, it's a block sitting on top of it, and the question is, at what point, if it's simple harmonic motion with a period of 1 second, right? At what amplitude will the block separate from the piston? Okay, so the piston's doing what it wants to do independent of the block. The block's just sitting on it, right? Like if I'm holding my hand and going up and down with my hand, at what point does the pen come off my hand? Right? Well, it'll come off my hand if what? I can just be still and have it come off my hand. Why does it come off my hand? Because the acceleration of my hand down is faster than, or is greater than, the acceleration of gravity. Right? So once the acceleration of my hand down is greater than the acceleration of gravity, the pen comes off my hand, because the only thing making the pen move is gravity. Right? All right, so if you turn to chapter 15, the end of the book, end of the chapter, all right, we have, is it the end of the chapter? Maybe. All right, so if we have the position, right, if the position is some max cosine omega t, I'm not going to worry about the angle right now. If that's its position, then what's its velocity? Right, is dx dt. Sine. Right? And then its acceleration. Yeah. All right. So because we know it's simple harmonic motion, we know its position is just a simple sine or sinusoidal. So you can start with cosine or sine, it doesn't matter, right? And we know that, because the difference between cosine and sine is just a phase angle, right? We know that the velocity goes then as a sine, the acceleration goes as a cosine. And so in part A, what is the amplitude at which the piston and the block separate? Well, it's not going to separate on the way up, right? But when it starts heading down, that's when it's going to separate. And so we're looking for the point at which this A equals to A max, right? Omega squared xm, right? That's our maximum acceleration. It occurs, well, it's negative because it's downward, right? But the magnitude of it is omega squared xm. It occurs at the top of the arc, right, or the highest position that the piston goes to, and we need for this to be greater than g, right? So we're really looking for when is it equal to g to find out what is our maximum frequency we can go to, or our maximum amplitude we can go to, right? Because we've got the period. We know that omega is 2 pi over the period, which is 2 pi over 1 second, right? That's omega. We know, and now we're just solving for xm. So xm is 9.8 meters per second squared, right? All of that divided by 2 pi per second. So 9.8, oh, not what I meant to do, it's what I did. There we go. 9.8 divided by 2 divided by pi. So we get amplitude of 1.56. All right. Once we get to this amplitude, the acceleration downward is high enough that we're going to, I did that wrong because it's omega squared. Okay. Here's a great thing about Excel. .25. Right? So once the amplitude is this high, why does it depend on amplitude? And just intuitively, why is the acceleration greater as the amplitude increases? Well, the period is the same, 1 second, right? So now I'm telling you, you've got to run back and forth further, but you still got to do it in 1 second, right? So the only way to do that is have the acceleration go up. All right. All right. Part B in this is if the piston has an amplitude of 5 centimeters, right? So now we're going with x max equals 0.05 meters, right? What is the maximum frequency for which the block and piston will be in contact continuously? Well, it's the same problem. We're still looking for omega squared xm equal g, right? But now we're solving for omega. So omega is square root g over xm is 9.8 meters per second squared over 0.05 meters. All right. So 14 per second, and it asks, that's radians. There we go. It asks for, but it asks for frequency. So this is the angular frequency, but most people would think of this in terms of omega equals 2 pi f, f, right? And so f is 14 over 2 pi seconds. 2.2 or 2.2 per second. Right? Straightforward problem, just depends on understanding the relationship between position, velocity, and acceleration. Right? Same thing we did way back at the beginning of the semester. And I'm going to skip around a little bit to make sure we sort of cover every chapter. Let me hit done.